Today we're going over 7-3, and that's Triangle Similarity. So, we learned before that triangles are similar, or polygons are similar. We're just focusing on triangles, but polygons are similar if they have the same shape, but not necessarily the same size. So, the true requirements are congruent angles and proportional sides. So when we are looking at the different types of similarity, you'll see angle-angle, side-side-side, and side-angle-side. If you remember, these are the same terms we learned before when we were talking about congruence, but this time we're not talking about the triangles being the same, but we're talking about them being similar to each other. So there may be some questions where they ask, how are the triangles similar? And you want to be able to tell how they're similar, and it's a lot like the triangle congruence things that we used. So if I look at the triangles below, the requirements for angle-angle similarity is that if two angles of one triangle are the same or congruent to two angles of another triangle, then these two triangles are considered similar. So triangle ABC is similar to triangle DEF. The next set is side-side-side similarity. So basically, if three sides of one triangle are proportional to the three corresponding sides of another triangle, so it's really important they have to be corresponding, the same spot or same position from one triangle to another, then these two triangles are similar to each other. So a good example would be if I told you AB was 5, DE was 10, and I told you that AC is 15, actually. Let's see. And I told you that BAC was 20. So that would make this 30 and 40. So the way I would find out they were proportional is that I would just go over them. So AB is 5, and DE is 10, so DE over AB then I can see DF and AC, 30 over 15, and EF over BC, 40 over 20. So I can see that from ABC to DEF that the triangles grew from a scale factor of 2. So that's the similarity between them. And this has to work for at least 2 of the sides. If I can prove 2 of the corresponding sides on each triangle are similar to each other or proportional, then we can assume that the third side is also going to be proportional as well. And our last one is side-angle-side similarity. So in this one, if two sides of one triangle, so AB and BC, DE and EF, if these two corresponding sides are proportional to each other and their included angle, which means the angle in between the two corresponding proportional sides, so B and E have to be in between, then if they're congruent, then these triangles are considered similar. So a good way to look at it is I'm looking at the side, the angle, and the side. Side, the angle, and the side. So I'd have to be able to prove, we already know angle B is congruent to, angle E. So let's say again this was, maybe this is 10 and this is 20. This is 20 and this is 40. When I compare them, and then I use my other side, oops, that's not right. They both are come out to be 2. So I know that AB is proportional to DE. Here's my angle, those are congruent. BC is proportional to EF. So side, angle, side. Okay, let's take a look at our first example. The first example says, explain why the triangles are similar and write a similarity statement. Okay, so I have triangle ABC and triangle DEF. They look like they might be similar, but I don't have the same amounts of information that I had before when explaining the different similarities. So let's take a closer look. I have angle A is 43, angle B is 90, and angle C is unknown. Well, I can figure it out. So I can look at it and say 90 plus 43, that gives me 133. And then if I take 180 and subtract 133, angle C is going to be 47. Okay, well now I can see that this is going somewhere. So if I add 47 and 90 on triangle DEF, I get 137, and when I subtract that from 180, I get 43. The shortcut would have been just to subtract 47 from 90, since angle A and angle C and angle D and angle F are complementary, so they will equal 90 degrees. So I can see I have the same angles, but my triangles aren't really facing the same direction. So if you have a hard time figuring this out because they're not in the same direction, you can redraw it. Looks like all I have to do is flip this big triangle on its side to where E and F is facing downward instead. Then I'd have the same orientation. So I can see that angle A corresponds to angle D, and angle B corresponds to angle E. So that's pretty much enough. I just have to pick two congruent angles on each triangle that are corresponding to each other. And so if I can do that, then I know that the triangles are similar. So let's say I'm going to use to write my similarity statement. Angle C is 47. We know that by the triangle sum theorem. So angle C is congruent to angle F, and angle B is congruent to angle E. That's all we need, is just at least two angles. So they're both 90. So that means that these two triangles, triangle ABC, is similar to triangle DEF by angle-angle similarity. Let's try our next one. Okay, example 2 says verify that triangle TXU is similar to triangle VXW. Well, again, I can see that the triangles aren't facing the same direction, but I can tell what sides are corresponding to it. So TX corresponds to VX, and UX corresponds to WX. So in this case, they gave me two sides. So if I can figure out that these two sides, these two corresponding sides, are proportional, I can assume that the third side is also going to be proportional. I just need to figure out two of them. So let's try TX and VX. So I have TX over VX, and TX is 12, VX is 16. That comes down to 3/4. Then I look at my next two corresponding sides. I have UX and WX, and I have 15 over 20, and that also comes down to 3/4. So that tells me that triangle TXU is similar to triangle VXW by Sideangleside similarity. Okay, example 3 says explain why triangle RSV is similar to triangle RTU, and then I have to find RT. So in this example, I'm looking at two triangles. I have RSV, and then I have RTU. So the smaller, and then the larger. So I have to try to prove the similarity. And I look at the information they gave me. I have a side, an angle, and a side. And I'm missing a side here. RT is what I have to find. I have an angle, and I have a side. So I think I can prove this by Sideangleside similarity, but we'll have to go through it to figure it out. So if I look at what they gave me, I can use SV and TU. So let's put those together and see what the proportion is going to be. So SV and TU. So SV is 8, TU is 12, and I can probably reduce that down to this would reduce down to 3 over, oops, that's wrong, 2 over 3. Okay, so hopefully that means that RT has to be of the same proportion. So I can try to figure it out by doing that. Okay, so next I set up my sides that are corresponding. So I have RS over RT, and we've already established SV over TU. So then I set up my proportion. So I'm going to have 10 over X, because we don't know what RT is, and 8 over 12. Then I set up my proportion, and I'm going to cross multiply. So I have 10 times 12, which is 120, and 8 times X, which is 8X. When I divide on both sides by 8, X equals 15. If I want to check my answer, and I want to make sure it's the same ratio, I can do 10 over 15, and that will reduce down to 2/3. So I know that this is right. So if that's the case, this whole thing right here is going to be 15. So then I know that this is similar, these two triangles are similar by the sides, the angle, and the sides. So triangle RSV similar to triangle RTU by Sideangleside similarity.